Hello friends, welcome to G-Centric. So in this lecture, we will start with our new chapter, that is three-phase circuits. Okay, so talking in gate point of view, three-phase circuit is very important for electrical branch as well as for the instrumentation branch. Okay, for EC there will be a minimum question, like a simple question will be asked. It will not be complicated, but if you will learn and go this chapter, okay, so you may attend 1 mark question very easily, okay, so that it can improve your score. Now coming to this three-phase circuit, where it is used, okay, before that, in this three-phase circuit we can classify as one-phase circuits, two-phase circuits and three-phase circuits, right? They all have got different applications, okay, in among which this one phase is used for domestic, okay, whatever supply we get it from one phase supply, right? We do not use three-phase supply. So this three-phase supply, where do we use? It's for industrial purposes, okay. Why? Because for the domestic use, we do not have that much load which draws the three-phase power. Okay, so we use only single-phase power. Two-phase, it depends on the application. This is not so widely used. Okay, so one-phase and three-phase, we use it a lot. And industrial, why is it three-phase? It's because of the loads. And what type of loads will be there? It will be most of the cases, 80 to 85%, we will be having inductive loads. Okay. Now coming to this first phase, that is single phase. We will study about this single phase system. Okay. In this case, there are two cases again. Okay, one is single phase two-wire system. Okay, and the third is the second is single phase three-wire system. Okay, so what do we mean by this? In the sentence itself, we know if one phase is there, then there will be two wires only, and this is three wire. There will be three wires. Okay, so how? We will see the first one. What is the first one? We have single phase two wire system. Okay, we have already seen this in solving the network problems, right? So it will look the same. Here we will be having a supply. Okay, this is V angle 0 degree. Okay, and see, this is one wire and this is the second wire where we will be having this load connected. And what type of load? Inductive. Okay, you can take any type of load. Okay, so now this point we will call it as phase and this is neutral. So in between these two, this is neutral phase and this is neutral line and this is phase line. Okay, so this is one wire and two wire, hence two wire system. Okay, now in this only we have got three wire single phase three wire system. Okay, so this 5 will represent the phase. Okay, representation of phase in network. Okay, now I will take three wire system. This is one voltage source and this is second voltage source. Okay, this is one, second and third wire. Now the twist in this here is, most of you don't get confused with these two sources. When it comes to sources, most of the students, what they do is that they think it as a two-phase system. Okay, but we will be having the same angle displacement for these both voltage sources, which means they have single phase only. Okay, if it was two phase, then here it would have been a 90-degree displacement. Okay, but here this is single phase. Okay, so the angle will be same. If here it is 0 degree and here it is 360 degrees, still both are single phase. Okay, it will come in the same rotation as well. Now I will connect a load over here. Let us call ZL1 and this is ZL2. Okay, this terminology is indicating that it's an inductive load. Okay, now this is phase 1. Okay, you can call this as A, this as neutral wire. Okay, and this as B. So in between whatever there is a voltage, we will call it as VAN and this is VBN. But they do not have any phase displacement. Both angle will be same. Okay, now this is two wire system. This is the most used type of single phase system. Why? Because Why do we use this is widely used? That is because we have from this wire we can draw 120 volts as well as 240 volts. Okay, so this is, if this is 120, okay, and volts, then this is also will be like 120 volts. Okay, and when we add this together we will get 240 volts. Okay, so both supply you can draw together. That is why it is the advantage of this one phase 3 wire system. Now coming to 2 phase system. Okay, how does this look now? It also looks like the same thing like single phase 3 wire system, but here the displacement will be, okay, let us draw this one, 2 phase system. Okay, we will be having 2 sources, okay, and here is 3 wires. This is ZL1, this is ZL2. Okay, this is V angle. If I take this voltage source as 0 degree, then it will be displaced with 90 degree. Okay, so this means it is 2 phase system. Okay, same angle single phase 3 wire system, different angle 2 phase system. Okay, here also this is A, this is neutral and B. Okay, there is one more formula to find the angle displacement. We will see after seeing the 3 phase system. 3 phase system. Okay, so in this one there will be 3 voltage sources. Okay, this is 1 voltage source, 2nd voltage source, 3rd voltage source, and there will be a neutral. So you can call this as 4 wire system. Okay, this is applicable for star. For delta it is not 4 wire system. This we will see in the next upcoming lectures why it is like that. Okay, so let us take ZL1, ZL2 and ZL3, and let us connect this all together, and this is neutral. Okay, N, and this phase is A, B and C. Okay, now this is V angle 0 degree, and there will be a 120 degree displacement, minus 120, okay, with respect to this source, and next there will be again minus 120 displacement, together adding will get minus 240, or you can write this as 120 degree. While drawing the phasor it will come and stand at the same point. Okay, so this is 3 wire system. Now since this neutral is connected, what will be the voltage across this one? It is VAN, this will be VBN, and this will be VCN. Okay, so this is 3 phase system. Now how did we find it as minus 120, minus 240? Why did the displacement come? We will see it in the next lecture. Okay, now coming to the formula section to calculate the angle displacement, okay, between the phases. What is the formula? Angle displacement will be equal to 360 by N. Okay, where this N is number of phases. Okay, now coming to this first phase, for single phase N is equal to 1. So what will be the formula? 360 by 1. Okay, so it will be equal to 360 degree. So here whether it is 360 or 0 degree, both mean the same. Okay, next coming to 2 phase system. So N will be equal to 2. Okay, now put N is equal to 2 in the formula. 360 by 2 will get 180 degree. But what we have seen here, it is minus 90 degree. So this formula is invalid for 2 phase system. Okay, for 2 phase it will be minus 90 degree displacement only. Okay, next coming to 3 phase system. N is equal to 3. So our displacement will be 360 degree by 3. So it will be 120 degree displacement between all the 3 phases. Okay, that's why we have written 0, minus 120 and minus 240 degree. Okay, so this 3 phase system, we'll call it as polyphase system also. Okay, that is because more than one phase we'll call it as polyphase. Fine. So this is the Three-phase circuit introduction. In the next lecture, we will draw the rotor and stator and see how the displacement works and what we call by positive sequence and negative sequence. Okay. Thank you.